All right, here is a quick how-to video for assignment number 1 on semester 2, your day 3 assignment. This is a work sample assignment, so I need to collect your work sample, like all this work that you would show, and you need to take a picture of it and attach it to your Google Classroom assignment. There will be an assignment in Google Classroom under day or week 1 assignments. It'll be listed as day 3, and just make sure you attach your work. All you have to do are 5 problems. You have to do 1, 5, 9, 13, and 17. So it's just every 4th problem starting with number 1. Now I want to show you how to do ones that are very similar to those. So I'm going to do, 2, 6, 10, 14, and 18 for you. And they are right here. So I'll walk you through them. So you'll write the problem on your paper. And then if you're taking a power to another power, you always multiply. So I put a 1 under the 3 so that we could multiply across on the fractions. So you get 3 over 2. So that's a good answer, right? 14 into the 3 over 2 power. But whenever you have a fraction as your exponent, the top number represents the power, and the bottom number represents the root. And so I need to fix that because when I did that originally, I put the wrong 1 on there. So let me fix that for you real fast. It would be the top number is the power and the bottom number is the root. And whenever you see a square root like that, you actually don't need the square root. You could get rid of it and it's the same thing. So the square root of 14 to the 3rd power would be a good answer right there. Let's see. Then you go to number 6. Now 6 has a -1 as an exponent when they're multiplying these two with fraction exponents. Well, whenever you're multiplying the same big number, you're going to just add your exponents. But this little -1 is a tricky part because a negative exponent actually takes this whole thing and puts it on the bottom of a fraction and just puts a 1 on top. Whenever you see a -1 exponent, it's just going to flip it on the side of a fraction. So if it's already at the top, you put it at the bottom. If it's at the bottom, you put it at the top. And like I said, when you multiply the same big number together, you add their exponents. So -3 halves and 1 half is going to be a -2 halves, which is actually a -2 fourths. -3 fourths plus 1 fourth, -2 fourths. You got to subtract those because they're different. And so you reduce this to -1 half. Well, again, it's a negative exponent. So now I got to put it back on the top with a 1 on the bottom. I don't need to put a 1 there. So I'm just going to leave it as 7 to the 1 half power is a good answer. But power of 1 and a square root of 2, you could actually just put radical 7 and you'd have the same answer. So that was number 6. Number 10, if you're multiplying the same root, you can just multiply the inside numbers. So you're going to keep your 4th root, since they're both 4th root. Only works if they're both the same root. And then you can multiply the inside numbers. Now, the 4th root of 81 has a number. It's 3. There are 4 3s that would multiply together to give you 81. So you got to know this 4th root means what one number can you multiply by itself 4 times to get this 81, and that would be a 3. 14's a little bit tricky because they're giving you the 3rd root of 9 divided by the 3rd root of 4, and you're not allowed to have a radical or a root at the bottom. So we got to find something that's going to be a whole number. The closest is the 3rd root of 8 because 2 times 2 times 2 actually is 8. So the 3rd root, or the one number that you could multiply by itself 3 times, would be a 2 there. So I need to get this 3rd root of 4 to become a 3rd root of 8. So I need to multiply 4 times 2 to get the 8, but I got to keep the 3rd root because they got to both be the same root. So if I multiply these two together, I get the 3rd root of 8, which comes out as a 2. And now it's perfect because we don't have a radical on the bottom. Whatever you multiply the bottom by, you have to also multiply the top by to keep it equal, to keep it an equal value. So 3rd root of 9 times the 3rd root of 2, since they're both the 3rd root, we can multiply the 9 times the 2 and get the 3rd root of 18. So your answer there, 3rd root of 18 over 2. The last one here is a little tricky because you, again, can't have radicals on the bottom. So you want to get rid of the radicals. from the bottom. To do that, we have this thing called rationalizing the denominator. And you learned it in Algebra 2 second semester, if you took it already. Rationalizing the denominator means you're just going to take whatever they give you as an addition and use the same two numbers as a subtraction. And you'll end up cross-canceling the middle terms, is what happens. So if you see this now, so I'm going to say if it's radical 2 plus radical 5, I'm going to do radical 2 minus radical 5. And I'm going to do it on top and bottom. So I can just distribute this top. 8 times the radical 2 is just 8 radical 2. 8 times the radical 5 is just 8 radical 5. I'm going to have the minus there. And then on the bottom, I need to do FOIL. Radical 2 times radical 2. Now, whenever you multiply the same exact radical together, that number comes out. Radical 2 times radical 2 would be a radical 4, but that comes out as a 2. And then you get a negative radical 10. 5 times 2 is 10. And a positive radical 10. 5 times 2 is 10. So those cancel out. So your radicals are all gone. Because radical 5 times a negative radical 5 is going to give me a negative 5. Because radical 5 times radical 5 would be radical 25, but that comes out as a 5, and they're different signs, so it's negative. When you combine your like terms, 2 minus 5, your bottom is going to be negative 3. The top didn't change. It's still 8 radical 2 minus 8 radical 5. The bottom's a negative 3, and that is completely simplified. So that should help you understand how to do your 5 problems, which is 1, 5, 9, 13, and 17. Do those 5 on a piece of paper, turn it in, double points, because it's a work sample, so I need it. I need it really badly, so thanks.